Friends, today I am going to make a video on lifting chain. There are three categories of chain are used in industries. Basically, they are denoted by grade. There are alloy steel. This in grade are generally there are three categories: grade 80, 100, and 120. The more the grade number, this is 100 and 120 will be better than 80 in terms of strength. But most of the industries, they are using grade 80. Grade 80 sometimes known as grade 8 or system 8, or they are marked as MA8 in the tag, manufacturing tag. You will see grade 8 means MA8 is written there. Okay, these are nothing but high strength to weight ratio. They are having making them suitable for heavy duty lifting and as well as lowering application. So these are the chain. Okay, sometimes we are using chains in chain blocks also, but chain blocks is having defined capacity, but ultimately it depends upon the chain you are using. The capacity can vary. So whenever we are going to calculate the capacity, beside the alloy, beside the material condition, we should also understand how we are using at the point of application, the lifting speed, lifting velocities, and all parameters are considered. So one by one we will discuss how the load is calculated. See there, the slings can be single leg sling, can be multiple leg sling. Ultimately they are connected to a common ring, and so as per their number of legs, load capacity can be varied. So first of all, what are the things? Working load. First thing we will calculate working load. What is working load? WLL, working load limit. This working load limits of chain string generally given by manufacturing and it is written on the tag itself, and you should follow the manufacturing guideline for this. However, in the case of your grade 8, we can take the load capacity, that is working load, to calculate by diameter square divided by 32. Actually, three categories of loads are there, that is your proof load as well as braking load. First we know braking load. At the braking load means all factor of safety etc. are not there. Maximum load it can break out, that can be actually d square by 8. Suppose it is a 8 mm grade A, 8 mm grade A sling. Definitely it will be 8 square by 8 ton. That is braking load. Next it is coming proof load. Proof load is d square divided by 16, double divide by, so it will be 8 square by 16, so it will be 4 ton. Next at WLL, working load. Working load is calculated d square by 32, means if it is 8 square divided by 32 means 2 ton. Like this working load is calculated. Okay, so before analyzing the safe working load, we should know some other things also, because many cases we are using multiple chains and they are forming one angle beta, okay, from the vertical. This angle to be taken in consideration while calculating the load for multiple slings. For single sling it is no problem, 90 degree, so factor is taken as 1. But for multiple load, there are two categories, one 0 to 45 degree, another is 45 to 60 degree. This position, this degree can be used. Okay, accordingly this chart has been made. So you will remember this is generally generated by, whenever you will find the WLL, if you find the WLL and you multiply them, this factor will come. Factor is nothing but your WLL into cos beta. What is the angle is divided cos beta? Cos beta is nothing but this base divided by hypotenuse. Okay, the length of the sling. So height by length of the sling, you can find out cos beta. So WLL into cos beta, you can find out factor. This factor depends upon number of lengths, number of legs, as well as variation of angle. So say it is for single leg. So there will be 5 categories. Single leg means 90 degree. Both the cases it will be 90 degree. So factor will be 1. If it is two legs, one position is 0 to 45. In that case, factor will be 1.4. Another case is 45 to 60 degree. This case, your factor will remain 1. Take 3 to 4 legs. In this case, 0 to 45 case, factor will be 2.1, and 45 to 60 degree case, factor will be 1.5. You can remember all this. This is the 5 cases generally coming in the formation of chart also. In the chart you can see how they have managed. This is the dimension of the dia of the sling, say 8 mm. It is 2 ton is given. We have already shown W working load, and if his factor is given 1.4, it can come this 2.8. Similarly 4.255, 2.1, like this. It will increase as per chart. Okay, so now we will see grade 8 10 mm dia rope, grade 8. Okay, take this rope. So how to calculate working capacity? Okay, this we will take one leg as well as 2 leg. First of all, calculate WLL for one rope, one single leg. Okay, how much it will be? It will be d square by 32, means 10 square by 32. How much it will be? 3.125 ton. Case 2. Now you got this is the ultimate WLL for single leg. Now safe working load, SWL, this is factor of safety into WLL. Factor of safety for single leg is 1, this one. So WLL is 3.125. So it will be actually 3.125 ton. Now in generally, factor of safety also taken as considered. That is generally for industrial rope is 4. So allowable load is not a safe working load. This can be 3.125 divided by 4, means load by factor of safety. How much? It will be 0.78 ton. Now take this same case for 2 legs. 2 legs 2 legs means factor of safety is, so SWL will be what? 1.4 factor of safety into WLL, that is 1.4 into 3.125. okay, that will be 4.375 ton. This is actually what is SWL. SWL is 4.375 ton for 2 legs. Single leg is 3.125. But allowable load is what? Allowable load divided, that is SWL divided by factor of safety. That's mean 4375 divided by 4. Okay, this will give you how much? This will give you 1.093 ton. So ultimately 2 legs, for 3 legs you can lift 1 ton, 1.09 ton. For single leg 0.78 ton it is allowed, though safe working load is somewhat different. Okay, I think you understood how to calculate the lifting capacity, okay, of chain. Thank you for listening.